2007 Nissan Frontier with an Evap large leak code. It is a P0455 fault code. I'll get you a shot of that. And that is the only code that's in memory on this vehicle. No drivability complaints, just the check engine light that's on. My class and I went through this earlier today. They're gone for the day. So this won't be a live run through of what we did, but I wanted to show this because future classes need to see it and you guys need to see it. The timing of this vehicle couldn't be better. We just finished section 3 in my book and in my class. The material that I teach in section 3 deals with output solenoids, and what you're going to find in this video with this particular problem is a good reinforcement of how to check a solenoid. So that's enough of the intro. Starting off with a leak test, the first thing that we look for is some type of service port, and as you can see, this vehicle has one. So I've adapted a tool. It's just a piece that depresses the Schrader valve that's inside. So you just wind this on here, and then I'm attaching a Evap smoke machine. The tool I'm using this time, it's actually called a Smart Smoke, and it's by Snap-on. And I'm really excited about this machine. We just got it here at the school, and what's nice about the machine as opposed to some of the other ones that we've used in the past is this tool provides me with multiple gases that I can use. Let me show you the back of it just real quick. We won't spend a lot of time with this, but as you can see, I have a a CO2 tank that adapts to the back of the machine and makes it a lot safer for doing evap leaks. You know, if you think about doing an evap leak with shop air going into the car, you're putting oxygen into the tank, and it really is a dangerous combination to have fuel vapors and oxygen together. So I really like the idea of having the CO2 tank, and we can actually pick which one. If I power this down and power it back up, the initial settings that come up, I can pick air or nitrogen, N2, or CO2. So basically I'm telling my tool what I'm using, and I like that feature. So let me get you a little bit of a close-up shot here of the tool. The rest of our settings before we use this, let's talk about a couple other things here. We have orifice sizes here, and yeah, we can definitely see the LED light. So for 99 and older vehicles, a 40 thousandths leak or greater sets a fault code, and 20 thousandths for 2000 and newer. And I'm just reading out of the manual that came with this, and I'm not sure totally about these numbers. And then this 10 thousandths one is apparently for future use. So it's kind of a pass-fail thing. And we also have a gauge up top. Unlike the other meter that I was using has a little flow ball, this one's digital. And all I'm going to do at this point is to select start, this 5-minute start. I'm going to leave it on the default 20 thousandths. And then we have the choice of looking at the leak size or our flow in liters per minute, I believe. The flow is the one I'm interested in, and this would be something that I've used in the past. And this is the first time I've used this tool. Actually, this is the second time I've used it, so you'll have to bear with me here. You see that just changed. Something I have here in my hand, which I think is really cool, is a remote control. One of the things that I've had frustration with in the past is doing a smoke test underneath the vehicle, and you know, you're connected to the battery up top, and then your smoke shuts off because it goes through a 5-minute cycle. So I can control it here. When you hear it clicking like that, that's just a lower flow test. That would be useful for doing, say, manifold gaskets or something like that, where you have smoke pouring out and you can't really tell where it's coming from. So that's pretty cool. I like the remote control feature. That's enough about the tool for now. You know, I'll do more tests with the tool and show you what else you can do with it. I am learning too. For now though, let's fix this car. We have a leak, and what we're trying to do is introduce pressure into the system, and then we watch this flow meter. We want to see this dropping off if there's no leak. Now, one of the keys with evap systems though, guys, is you have to understand that every evap system has a normally open vent. So we need to close that vent, and that is either done with the scan tool or it's done mechanically underneath. So do we have a bidirectional control to close this vent? We'll go to our actuator tests, and then what we're going to pick, we actually do have one, our vent control on off. This is our vent valve. There's some data parameters we can look at too, but for us, for this test, we're really just worried about whether or not we can close the vent. So what we're going to do from this screen, not really worried about our system data PIDs. Well, you could look at your evap pressure if you wanted to. But when we close this vent valve, what we should see is this pressure should be changing. Curious to see what that looks like with this off. Let me turn the smoke off for a second. Looking for a tank pressure change. So no real change there at all. And let's turn that back on again. That is with it smoking. So it's just a data PID you can look at when you're doing this. No change. So, do we have a large leak? It sure looks like it. Let's go underneath, see if we can see where the smoke is coming from. Another tip that we can do, I guess, before we do the smoke is to turn the valve on and off and listen for clicking. And I do not hear any clicking for this vent control valve at all. So that is a red flag that this vent control valve has an issue, and the reason we have a large leak code is the computer is not able to close this vent valve. So let's go underneath, see where the smoke's coming from. We'll come back to this valve. I'm going to leave this on while I'm leaving my smoke going into the system. You see we're reading 2.9 to 3. I'm assuming that's liters per minute, L/M, I'm guessing. I guess the first thing to show you before we go underneath is make sure your machine is smoking. And this is a UV smoke too, by the way, which is pretty cool. I have not used the UV smoke yet. Okay, going underneath. I'm not sure I can show you very well on camera where the smoke is coming from. You can certainly see the smoke. And if you look closely, there's a hole in the frame. That's really where it's coming from. So we have smoke coming out of the frame. Guys, what you need to understand about evap systems is they like to dump the vent into the frame. So what we're concerned about right now is our vent solenoid. So what I look for is a line, as you can see, that goes right to my frame. That is the discharge port of the vent solenoid. And what we can do before we do electrical checks, just to see if this is the area where our leak is, so we can block this off. So just taking a pair of needle nose vice grips, and I'm going to pinch that vent line off, which is going to eliminate the smoke from dumping in the frame, eliminate the vent valve from being open. Take you back up front, let's look at this flow meter. Well, you see it failed the test. Once it runs through that 5-minute smoke cycle, I didn't let you know about the PassFail. It's really not important to me right now. I want to look at this number, so I'm going to redo it with that vent now closed. Reading 2.8, 2.7, 2.6. So what we should see now, guys, if we're doing this correctly, we should see this number dropping. This is a flow in, I'm assuming again, liters per minute. I don't care about what the number means as far as the LM. All I care is I want to see that number dropping. And what this is going to tell me if there's no other leaks in this system, this number is going to drop all the way down to near zero. I'm not sure if it'll hit exactly zero. Let's keep watching it. This is a good sign so far that we're seeing this number dropping. Let me get you a shot of the scan tool. You can watch that real quick. We'll come back to this. You notice the pressure on the scan tool also changed on us. And we actually, the voltage rose, so we were at 3.8 and it's now at 4.1, so that's tank pressure. And we're putting pressure in the tank. We saw our tank pressure voltage change, which before we did not. So again, pointing toward the direction of a vent solenoid problem only. I'm going to let this run through the remainder of this smoke cycle. It's a 5-minute, and it'll give you a pass-fail on this. Not, again, that I'm worried about that. I'm more worried about the number. I want to see this drop all the way down to zero. We shouldn't have any flow in the system if there is no other leaks. Now, what you need to be aware of is it takes time for the system to completely fill before this flow meter will tell us that there is no more flow going into the system. The other thing that this thing will operate off of, if any of you guys have the electric or battery powered impacts, is it takes a battery pack, the same battery pack that I believe it's your 1/2 inch, I think it's the 18-volt battery that Snap-on makes on the back of this, and you don't have to use the car battery, so that's pretty cool too. So I'm looking for a zero myself. I'm not familiar with the tool. Am I ever going to see a zero? Cool, there it is right there. This is what we want to see. If there's no leak in the system, this is what we'll see. So you think about this for a second. If you start working on this vehicle and you're energizing the vent solenoid with the scan tool and you put smoke into the system and you run this down and you see a zero reading for your flow meter, there's no reason to get underneath it and start looking for smoke. So that's one. For us right now, what this means is absolutely our leak is that I cannot close the vent. So there are no other leaks in this system. What we need to do now is electrical checks at the vent solenoid. Well, fortunately for us in this video, where the vent solenoid lives actually makes for easy filming. I'm on the driver's side above the rear tire, and I actually have better access here than I do from underneath the vehicle. Let me get you one other shot. Half the battle in doing this kind of stuff is identifying where these components live. And what I did to know which one my vent solenoid one was is I counted the number of wires. So the one that I'm already back probed into is my vent solenoid, and the one to the right is actually my pressure sensor. And what I did is I used the number of wires to tell me that. So just a little tip, maybe, hopefully that helps one of you. All right, so the first thing that I like to do if I'm working in the field, now I did this a little bit differently with my class. I actually made my guys pull a wiring diagram and figure out how the solenoid was controlled. And the reason I did that is we just learned, like I said, section 3, where we go over transistor drivers and output solenoids, and part of what we do in that chapter is we talk about identifying type of circuit. So I wanted them to do that for practice. And there's other ways to do it too. If it's me and I'm in the field, the first thing I'm doing is 2 voltage measurements. So that's the way I'm going to do it with you guys. All right, there's the first of my 2 measurements. And by 2 measurements, I have 2 wires, so I'm just going to move this pin over. And that is the second of my 2 wires. So what we know here, guys, this is a ground side switch circuit. And now what I'm going to do is I'm going to command that solenoid on from the front with the scan tool. So with the scan tool, I'm just going to select on and off. I'll keep you guys focused up on the meter. And watch the voltage reading on this first wire as I turn it on. We had a slight voltage drop on that. This suggests current flow in the circuit, and it also tells me this is the feed wire. So really, believe it or not, that's enough. That's circuit off. Here's circuit on. This circuit's working as designed. That voltage drop on the feed is telling me I have control. I'll show it to you on the other wire. Moving back over to my other wire. So the one to the left is my feed. This one to the right is my control. There you see we're dropping voltage 0.33, 13, 0.32. And my students asked me this question earlier. You guys may have a question too, because I'm always talking about 12 and 0. This being on, it should be 0, off should be 12, ground side switched. Guys, there's a certain amount of current flow that's taking place in this circuit, and the ground wire integrity, the ground circuit integrity, there's resistance. The wire, the transistor, this is still 0 volts. It's 0.3. I realize there's some voltage there, but that is normal. So what we know, electrically speaking, as I'm turning the solenoid on and off, there's nothing wrong with the electronics. And that means this solenoid is bad and it is stuck in the open position. Now what would be really cool is if I can unstick this for you guys. Again, turning this on and off, we should be hearing clicking, we're not. Let's get a pry bar here. I don't know if this will work or not. What I'm going to do is turn it on, energize the circuit, and I'm going to take this and just smack on it. It'd be cool if I could unstick it for you. Nice. Listen, listen. I just heard it click. Let's try it again. I definitely unstuck it. I heard it. Solenoid off. Nice. Solenoid on. I don't know if you heard that click. Solenoid off. Solenoid on. That's cool. Alright, so now I'm back on. I'm going to go underneath and take my vice grips off. We're going to redo this test again with this solenoid energized. One of the things we don't want to do is leave vice grips on customers' cars. I've done that before. It was a friend's car too, and he called me up and said, "Hey Paul, why can't I fill my gas tank?" Well, that's because vents are normally open, and when you leave a pair of vice grips on someone's car, that can happen. So don't do that. Learn from my mistake. Let's listen to it again. I'll turn it off. Turn it back on. Alright, right now that solenoid is energized. Let me take you back up front. Let's redo this check. Here's a shot of our tank pressure. Evap tank pressure. Solenoid is on. 3.9 volts. Back to our tool. And I have the system empty right now. So we're going to watch flow again. When I say system empty, I meant empty of pressure. I do not have the vice grips on this, guys. In fact, I'll show them to you. They are right here in my hand. This is not what we had before. We had a number, this flow number, that was not dropping. It only dropped when I put the vice grips on it. What are we seeing right now? Since I unstuck this vent solenoid, what we're seeing is a drop in flow, which is telling us this system does not have any leaks right now. So let me ask you guys, are we 100% confident we need a vent solenoid? And I'm sure you're saying yes. What if I couldn't unstick it? What I showed you guys, is there enough evidence to change that vent solenoid even if we couldn't hear a change and a click? The answer is yes, guys. You have to trust your voltmeter. You have to trust your knowledge of circuit design, ground side switching, knowing that the computer's doing what it should be to that solenoid and that that solenoid is not closing. All of that we cover again in section 3 of my material. We just finished that for this week. So for you guys that are watching and following along, this is a great review of a ground side switch solenoid and how to energize it and how to test it and normally open solenoid that closes when it's energized, all that stuff, again, we talked about this week. But this is my father-in-law's truck, so the question is, are we father-in-law confident that we're making the right call on this vehicle? I know I am. We're definitely putting a vent solenoid in this. As far as an after repair video, guys, I don't need to show it to you. Right now, this solenoid that's in there is working like it should. Watch the pressure when I shut it off. I just shut it off bidirectionally. You see we got a whole bunch of flow now. That's pretty cool. And I just turned it back on electrically and it is not functioning. You see that number's not dropping, but if I go back and bang on it, you can just hear the noise. I'm not going to move the camera. Watch the flow meter. Call me a liar. Solenoid is on electrically. I'm going to do that again. Cool. So now you guys understand this flow meter a little bit more. That's really why I showed this last step. What's it look like when there's a massive leak? Is you don't see that number dropping. What does it look like with the vent solenoid closed? This number will drop and drop and drop. And depending on the leak will be whatever that number, that flow meter shows you. And there's different ways to look at it. This is my preferred method so far on this tool. I'm going to take the scan tool one more time and not unstick it, turn it off. Vent solenoid is off right now. Okay? Alright, so hopefully you guys learned a little bit more about evap systems and leak testing. Again, we're using a CO2 container to do it. I like that a lot better than compressed air. It's a pretty cool tool we have. And I think I'm going to have a happy father-in-law.